What if I told you there's this incredible way to think about the future, and that the key to unlocking it was actually written by a countess back in the 19th century? It's true. She saw the world not just as it was, but as this giant puzzle that could be solved. And, her way of thinking is more important today than it has ever been.
So I've got a question for you. What on earth do cupcakes, a cat named Puff, and the entire future of technology have in common? I know, it sounds like the beginning of a weird joke, but the answer isn't a what, it's a who. A total visionary who lived almost 200 years ago.
And that person is Ada Lovelace. She is the key to this whole puzzle. We're talking about the Countess who basically wrote the world's first computer program 100 years before the first real computer was even a thing. Her story is where this whole journey begins.
Now, you've probably heard of her dad, the super famous and kind of wild poet, Lord Byron. Well, Ada's mom was this brilliant mathematician, and she was absolutely terrified that Ada would inherit his poetic, unpredictable nature. So in this amazing twist, she did everything she could to steer her daughter away from poetry and pushed her, hard, into the superstructured world of logic and math. And her path from there was just remarkable. She was tutored by a top scientist, and then, as a teenager, she meets the inventor Charles Babbage. This meeting, this partnership, led to a huge breakthrough. In 1843, she was translating some notes about his theoretical analytical engine. But she didn't just translate them. She added her own notes, including this incredibly detailed, step-by-step method for the machine to do a really complex calculation. And that is now considered the very first computer program ever written. And this, right here, is the really crucial part. Babbage, he saw his invention as a powerful calculator, but Ada? Oh, she saw so much more. She had this flash of insight that if a machine could manipulate numbers, it could manipulate anything that could be represented by numbers, like symbols, musical notes, or even images. This was the giant conceptual leap that basically predicted modern computing.
So that visionary leap she made? Well, that's the core of what we now call computational thinking. And here's the most important takeaway. It's not really about thinking like a machine, it's about learning how to break down problems in a way that a machine can help us figure them out.
To put it really simply, computational thinking is just this super powerful way of tackling problems by breaking them down into clear, logical steps. Steps so clear that, even a computer could follow them. And as we're about to see, it's a skill you can use pretty much anywhere. So it all kind of boils down to these 4 key ideas, or pillars. First up is decomposition. That's just breaking a giant, messy problem into smaller, bite-sized pieces. Then there's pattern recognition, spotting the similarities or trends in those smaller pieces. Next, abstraction. This is all about ignoring the distracting, irrelevant details and focusing only on what really matters. And finally, algorithms. That's just creating a simple, step-by-step recipe to solve the problem.
And it turns out, a simple cupcake can make this all crystal clear. Think about baking one. You use decomposition to break the task into 2 parts, making the batter and making the frosting. You use pattern recognition because the basic steps are the same for almost any cupcake. You use abstraction when you ignore details that don't matter, like whether you use red or blue sprinkles. And the recipe itself? Well, that's your algorithm.
The cupcake proves you really don't need a high-tech lab to get the hang of these skills. So let's check out some unplugged activities inspired by Ada's own life that teach this way of thinking without ever looking at a screen.
All right, first up, a classic puzzle that totally represents Ada's logical childhood. It's called the Tower of Hanoi. The rules are super simple, but solving it, well, that requires a very specific kind of thinking.
The goal seems easy, right? Just move a whole stack of discs from one rod to another. But here's the catch. You can only move one disc at a time, and a bigger disc can never, ever sit on top of a smaller one. To solve this, you have to think algorithmically. You have to come up with a clear, repeatable set of moves. You're literally building an algorithm with your own hands.
Okay, next up, we're going to move from pure logic to the actual language of computers. This station is inspired by Ada's cat Puff, who was apparently her only childhood friend, and it is all about cracking codes.
So here, we get to learn the most basic language of all computers, binary. It might look really intimidating, just a bunch of zeros and ones, but it's just a system. In this activity, you translate these binary codes into numbers, and then those numbers into letters, and eventually, you uncover a secret message. It shows you exactly how every single piece of digital info is stored. All right, this next station pays tribute to Ada's legendary teamwork with Charles Babbage. It basically asks the question that she was the first person to even think of. How could a machine, which only gets numbers, ever create an image?
And the answer is, well, computers don't actually see pictures, they just see data. We call this data representation. An image is just a grid of tiny dots, or pixels, and each one gets a number. So in this activity, you get the code, a list of numbers, that tells you which pixels to color in for each row. And when you follow that algorithm, a picture of a cat just magically appears, all from a list of numbers.
Okay, so we've played with some puzzles, we've decoded binary, we've drawn with numbers. It's all cool stuff, but why does this way of thinking from all the way back in the 19th century matter so much right now?
This is where it all clicks. Each one of those games was secretly teaching you one of the core pillars of computational thinking. The Tower of Hanoi was all about algorithms. The binary puzzle was about abstraction. The pixel art was a masterclass in data representation. See, they're not just games, they are literally training for your brain.
Because today, computational thinking is considered a fundamental, must-have 21st century skill. And this isn't just for coders or computer scientists. It's like a problem-solving superpower for doctors, artists, business owners, pretty much everyone.
And you know, the whole world is taking this really seriously. From the UK to Singapore, Australia to the US, countries are weaving computational thinking right into their main school programs. They recognize it's an absolutely essential skill for navigating the world we live in today.
So let's bring this all the way back home. How does any of this apply to you, like right now, in your everyday life?
Well, check this out. Ada Lovelace used this exact kind of thinking to design programs for a machine that didn't even exist. You use the exact same process to get ready in the morning. Seriously, you decompose the task. Wake up, shower, get dressed. You follow a pattern every day. You've created a super efficient algorithm to get yourself out the door on time. The scale is obviously different, but the thinking is identical.
The truth is, you are already a computational thinker. You use it all the time, to plan a trip, to organize a big project, even to cook dinner. The only difference is that now you have a name for it. So the real question is, now that you know what you're looking for, where will you see it? And how are you going to use this superpower to solve the next big problem you run into?